Bismillahirrahmanirrahim. Hello, my dear students. I hope you are all doing well. I welcome you all in class of O-level mathematics. In today's lecture, we are going to discuss PYQ's previous year questions from 2004 to 2024. And these questions are related to your topic linear inequalities in two variables. I am Azmat Ali and currently I am working as a lecturer in mathematics at Government Shalimar Graduate College, Lahore, Pakistan. In today's lecture, we will discuss question from 2004 to 2008. So let us start. You will see there are two types of questions every year asked. One is related to a linear inequality, and from this inequality we need to find integers that satisfy the given inequality. And the second one is a graph is given and we have to shade the graph with respect to the given linear inequalities in two variables. So our first question is, the first question is we need to find all integer which satisfied both inequalities 2x plus 7 less than 3 and x greater than or equal to minus 4 here. This is a simple inequality 2x plus 7 less than 3. By subtracting 7 from both sides, we have 3 minus 7. This implies 2x is less than minus 4. Dividing on both sides by 2, we have x less than minus 2. The second inequality is here, x greater than or equal to minus 4. We need to find all those integers that satisfy these two inequalities, x greater than or equal to minus 4 and x is less than minus 2. So the integers that satisfy both inequalities are, one is from here, because this inequality has greater than or an equal sign also. So one of the integer is minus 4 from this, and the second one is minus 3. Minus 2 cannot be included here because this inequality has no equal sign. We can see here this all situation on the number line. Suppose this is x is equal to minus 4. Now this inequality shows we need to all those numbers which are greater than or equal to minus 4. So this will be like in this direction. So this shows x greater than or equal to minus 4. Suppose here is x is equal to minus 2. Now this shows all those numbers which are less than minus 2. So the direction of these numbers will be, on the left side like this. But minus 2 is not included. Now the common area between both inequalities is this. So in this region, all those numbers that satisfied both inequalities are minus 4 and minus 3. These are the two numbers. (2004) paper 1, question number 16. This question is related to a graph. Question says the unshaded region R is defined by three inequalities. One of these is x greater than or equal to 1. Write down the other two inequalities. The marks of this question is 3. Firstly, we identify the equation of this inequality x greater than or equal to 1. You can see here the corresponding equation the corresponding equation to the inequality x greater than or equal to 1 is simply x equal to 1. X is equal to 1, this shows a vertical line. This shows a vertical line. Throughout the lecture, always remember, we will discuss three types of line. One is x is equal to some real number, x is equal to some number, some real number, some real number. Graphically, this line shows a vertical line. This will be a vertical line. The second one is y is equal to some real number, some real number. This always shows a horizontal line. This is always a horizontal line. And the next one is that consists on both variables at the same time, ax plus by is equal to c. This is a slanting or an oblique line. This is always an oblique line, or you can say this is a slanting line. So the next the first one is x is equal to 1. X is equal to 1. Yes. Where is x is equal to 1? If you see here, this vertical line represent x is equal to 1. This is x is equal to 1 here. Next, we need to find the other two inequalities. So firstly, we identified the corresponding equation of the line. You can see here the next line is here. This cut the y-axis at 3. So the equation of the second line, this is this green line, this represent y is equal to minus 3 here. Next third one is an oblique line. This one, this is your third and last line. This is your oblique line here. Now, what is the equation of this line here? This line, that is the oblique line here. Very simple way. If you see this line cut x-axis at 5. Similarly, this line again cut y-axis at y is equal to 5. So this line cut x-axis at x is equal to 5. That is actually, this shows x-intercept. What is this? This shows x-intercept. Always remember, the point where a line cut x-axis is called x-intercept. Similarly, the line where it cut y-axis is called y-intercept. So the y-intercept of the line is y is equal to 5. Now to find the equation of this line by using two intercept form of a line. Two intercept form of line. Two intercepts form of line. To intercept form of line having the formula x over x-intercept, that is 5 here, and y over y-intercept, that is 5 here, is equal to 1. The right side of two intercept form is always equal to 1. Now multiply on both sides by 5. We have x plus y is equal to 5. So this is the equation of the third line. Next we need to find the corresponding inequality here. To find the corresponding inequality, we need to determine the region, unshaded region. You can observe the unshaded region R is above this green line here. Here is your unshaded region. So in the unshaded region, all the points are greater than minus 3. So the second inequality is y greater than equal to minus 3 here. Next, for the Third inequality, again you can see here the unshaded region R is below this line. So the third inequality opposite to this corresponding equation, is simply x plus y less than or equal to 5 here. If you have any doubt about the sign, suppose here you have a doubt that this inequality should be x plus y greater than or equal to 5. Okay, you can take any point from this region R. Suppose in the region R we take this point. The coordinate of these points are x is equal to 2 and y is equal to 1. X is equal to 2 and y is equal to 1. If you put this value x is equal to 2 and y is equal to 1 in your inequality, you have 2 plus 1 greater than or equal to 5. 3 is greater than or equal to 5. Is this true that 3 is greater than 5? No, this is false. It means the selection of greater than or equal to sign is here not correct. So the correct sign is less than or equal. Next, the next trick that you can use here, suppose there is a person that is standing on this line here. Suppose this is a person that is standing on this line. I say the unshaded region R is below the person or above the person. It is on the below side of this person. So for the below side, you will always use less than, equal, or simply less than sign. It depends on the line. If your line is dotted, then you will simply choose less than sign. If your line is solid, then you will use less than or equal sign here. So this is the correct way to find the inequalities. Next we move towards the third question here. The third question, December 2005, paper 1, question number 14. In the diagram, the unshaded region R is defined by 3 inequalities. Two inequalities are given. Write down the third inequality. We need to find the third inequality here. Firstly, we identify the corresponding equations of these two inequalities. So here the first inequality is y less than or equal to 2x plus 2. One of the easiest method to identify its equation. Its equation is simply y is equal to 2x plus 2. Now, one of the easiest method to draw the graph of this equation or to identify the graph of this equation is simply we just we can convert it into two intercept form, or either by finding any x or y intercept we can identify the line that represent this equation. Suppose we put x is equal to 0 here. What will be the value of y? Your y is 2. This represent y intercept. Now check in the graph which line cut y-axis at 2. So you can see here this line. This line represent this line cut the graph, cut y-axis at this point, y is equal to 2. It means this line has the equation y is equal to 2x plus 2. The next one is, the next inequality is y less than or equal to 5 minus x. The corresponding equation is simply y is equal to 5 minus x. Similarly, as above, if you put x is equal to 0, you have y is equal to 5. This represents y intercept. You can see the line that cut y-axis at 5. This is your line. It means the equation of this line is y is equal to 5 minus x. It means we need to find the equation of the third line. This is our last line. We need to find the equation of this line. Here the method that we can use here, when graph of line is given and we need to find the equation of that line, we will take just 2 points on this line. From your grid, if you see, there are the 2 points that lies on this line. One is this. What are the coordinates of this line? Coordinates of the line that lies on third line, this is 2, 1. X is equal to 2 and y is equal to 1. And the second point that you can choose here, simply origin, because this line passes through origin also. So the second one is 0, 0. Now to find the equation of this line, we can use any of the following 3 formulas. Always remember, when we need to find the equation of the line, you can use either of these 3 formulas. The first one is, my dear students, y is equal to mx plus c. The second one, m is, what is m here? M is shows gradient of line. This shows gradient of your line. The second one is y minus y1 is equal to m times x minus x1. This is called slope point form of a line. And the last one is two intercept form, can be used x over a plus y over b is equal to 1. Here the number a is called x intercept and b is called y intercept. So I am using the first formula, that you are familiar with this formula already. So firstly I find the gradient of the line, that is m here. You know, formula is y2 minus y1 over x2 minus x1. What is y2? You can take either a point, any point. You can take, this is x1, this is y1. You can also take this as x2 and y2. If this is x1 y1, then this will be x2 and y2. So by putting these points in the formula, we have 2 minus 0 over 1 minus 0. So the gradient of the line is 2. Hence, by using the first formula, I will use here this formula, this form, y minus 1, slope point form. Y minus y1, y1 is 0, is equal to slope gradient x minus 0. So the required line is y is equal to 2x simply. It means the third line has the equation y is equal to 2x simply. So this is the first part that we have to complete it. Next, B, find the integer value of x which satisfy the following. This is a linear inequality and we need to find the integer values of x. Our inequality is 4 less than equal 2x plus 13 less than 9 here. By subtracting 13 from both sides, each side, we have 4 minus 13 less than or equal 2x plus 13 minus 13 less than 9 minus 13 here. This will become minus 9 less than or equal to 2x less than minus 4. By dividing on both sides by 2, we have minus 9 by 2. This will become minus 4.5 less than or equal x less than minus 4. All the integer values that lies in this interval R. This represent, you can draw this on a line here like as this. This is your x is equal to minus 4.5, that is included here, and this is minus 4, that is not included, so we draw here whole. Your common areas like in this interval. So the integers that satisfied this inequality, one is I think I have a mistake here. When we divide here by 2, this will become minus 2, sorry. Yes, now the integer that satisfied here, this interval, these are the two integers, one is minus 3 and other is minus 4 here. Next one, 2006 paper 1 question number 10, find the smallest integer k which satisfied this inequality, 7k greater than or equal to 36. If we divide k on both sides, simply we have k is equal to 36 by 7. 36 by 7. When you divide 36 over 7, we have k is greater than or equal to 5 whole number 1 by 7. So our integer, the smallest integer which is greater than this, because this number is greater than 5, so the smallest integer is 6. The next one, find the largest integer which satisfied this inequality. Our inequality is simply 3n minus 1 less than 26 here. By adding 1 on both sides, we have 3n less than 27. By dividing 3 on both sides, we have n less than 9. The greatest integer that is near to 9 but less than 9 is simply n is equal to 8. Yes. Next we have a graph. The diagram shows the graph of x is equal to 1, y is equal to 3 and y is equal to x minus 1. The region R is defined by the inequality x greater than 1, y less than 3, y greater than x minus 1. Given that the point xy is in the region R, find the integer value of x and y. This question is lengthy and I think the marks of this question should not be 1. Okay. The first line, the first line is x is equal to 1. X is equal to 1. As I said above, x is equal to some real number always represent a vertical line. So my dear students, x is equal to 1, this line represent x is equal to 1 here. Y is equal to 3, it will be always a horizontal line. Where is y is equal to 3? Y is equal to 3 is here. So this line represent y is equal to 3. So this is your second line. This is your second line, y is equal to 3 here. And the last one clearly represents y is equal to x minus 1. This line represents y is equal to x minus 1 here. So we label this line. This is your x is equal to 1. This is your y is equal to 3. And clearly this is the last line that shows y is equal to x minus 1 here. Now our required region R, this is our required region, is defined by the inequalities x greater than 1. X greater than 1 mean all those values which are greater than 1. So these are the values which are greater than 1. So your required region your required region lies that shows x greater than 1. These values shows x greater than 1. The next one is y less than 3. Y less than 3 mean all those values which are less than 3. Less than 3 mean below 3. So these are the values that are less than 3 here. The last one, y greater than x minus 1 here. Yes. Where is y greater than x minus 1? This line shows y is equal to x minus 1 and the points below this are y less than x minus 1. So y greater than x minus 1 represent this region. This is y greater than x minus 1. If you have any doubt about y greater than x minus 1, you can choose any point in this region. Suppose one of the point is here, x is equal to 2, y is equal to 2. If you put x is equal to 2 here and y is equal to 2 in this inequality, you will have 2 greater than 2 minus 1, 2 greater than 1. You can say this is true. So simply, this is our triangular region that represent the graph of these three inequalities. The last one, given that the point xy is in the region, find the integer values of x and y. We need to find all those integers values that satisfy these inequalities. There is only one point. There is only one integer value that satisfied all these inequalities, and that is simply x is equal to 2, y is equal to 2 here. That lies here in the region R. Suppose if you think x is equal to 2 and y is equal to 1 also lies in this region. If you think here, then if you think x is equal to 2 and y is equal to 1 also lies in this line, because the grid lines are not given in this graph. So you may have a doubt that this point also a point of this region R. You can simply check whether this point satisfied all these inequalities or not. If you put x is equal to 2, y is equal to 1 in first inequality is x greater than 1, 2 is greater than 1, this is true, this is true. If you put this point in second inequality, that is y less than 3, your y in this point is 1, 1 less than 3, this is also true. If you put this point in the last inequality, that is y less than x minus 1, if you put 1 and x is equal to 2 minus 1, 1 is greater than 1, is this true? No, this is false. 1 never be greater than 1. So this point does not satisfy the last inequality. It means there is only one integer value that lies in this region and satisfied all the inequalities. Next we move towards the question number 5. 2006 paper 1 question number 9. We have given an inequality. Solve this inequality. Just we have to solve inequality in part 1. Minus 7 less than or equal to 3x minus 4 less than 2. The marks of this question are 2. Nice. Adding 4 on both sides, we have minus 7 plus 4 less than or equal to 3x less than 2 plus 4. This becomes minus 3 less than or equal to 3x less than 6. By dividing 3 on both sides, that is the coefficient of x here, we have minus 1 less than or equal to x, x less than 2. So now this is our answer. In the next part, he says, write down all the integers which satisfy this. Now we have to find all those integers that satisfy this inequality. The integers that satisfied this inequality Yes, all those integers that lies between -1 included and 2 is not included here. X is equal to -1, 0 and 1. These are the three integer values that satisfy this inequality. Next we have, again we have given a graph. Question is of same year in the same paper 1, question number 17. The line L is drawn on the grid below. Write down the equation of the line. Very simple way. The first method is method 1. By using two intercept form of a line, you can write here x over y plus y over b is equal to 1, and mention in the paper that this is a two intercept form where a represents x intercept and b represents y intercept here. If you see, if you're not here, this is y intercept, and what is this? This is y is equal to 3, so b is 3 here. And the line cut x-axis at this point, and this point is 1.5, 1.5. Your a is 1.5, that is 3 by 2. So by putting these values of a and b in this line, we have x over a, that is 3 by 2, y over b, that is 3 here, equal to 1. The coefficients of x can be written as 2x by 3 plus y over 3 is equal to 1. Multiply on both sides by 3, we have 2x plus y is equal to 3. So this is the line, this is the equation of line L by using method 1. Now I discuss the second method. If you have any doubt about method number 1, if you see, you have to find any 2 points that lies on this line. So it is clear from the grid, one of the point is this point is actually y-intercept. So its coordinates are 0, 3, and this is this you can take this as a second point. This point is x is equal to 1 and y is equal to 5 here. You can choose any other point also. Suppose you can take this point also. This is x is equal to -1 and y is equal to 1. So let us choose with this point. X is equal to -1 and y is equal to 1 here. Now we find the gradient of this line, that is m. You can take this as x1, y1, and remaining are x2, y2. y2 minus y1, this is 3 minus 1. x2 minus x1, this is 0 minus 1. This will become 2 by 1. The gradient of line is 2. By using slope point form, y minus y1 is equal to gradient x minus x1, y1. What is y1 is here? 1. Gradient is 2. X minus x1, x1 is 0. So your line is y is equal to 2x. Your x1 is -1 here. This is -1 and this will become +1. So this will become y is equal to 2x plus 3. So by both method you can see the same equation. The third method that you can use here, you can take any point here. Suppose I again take this point. This point is x is equal to 1, y is equal to 5, and the y-intercept of this line is 3. Simply now use this equation. Y is equal to mx plus c, y-intercept is 3 and the slope is, that is a gradient, 2 here. So by just putting 2x plus c, what is c? C is 3 here. This is the method number 3. I have used the same points in method number 2 to find the gradient. Okay, draw and label the lines. Next we have to draw and label the lines. X is equal to 1. Where is x is equal to 1? Here. Just a minute. Here is. Okay. I have to draw x is equal to 1. X is equal to 1. This, this is a vertical line. My dear student, this is your x is equal to 1 line. This is your x is equal to 1 line. This green line represent x is equal to 1. You can adjust this. This is x is equal to 1. Y is equal to 3. Y is equal to 3 is always a horizontal line. Sorry. This shows your line y is equal to 3 here. Y is equal to 3. The last one, x plus y is equal to 2. X plus y is equal to 2. By dividing on both sides by 2, we have x by 2, y by 2 is equal to 1. This is the two intercept form of a line. This shows your x intercept is 2 and y intercept is also 2. It means this line will cut the graph at x is equal to 2 and y is equal to 2 here. So this is your y is equal to 2 and this is your x is equal to 2. By joining these 2 points, you can draw the graph of this line like this. More by extending this line more. So this represent the graph of line x plus y equal to 2. Okay. Shade the region which satisfied 3 inequalities x greater than or equal to 1. X greater than or equal to 1 mean the line, the values that are to the right side of x is equal to 1. So these will be these lines. These all shows x greater than or equal to 1, including these. Y less than or equal to 3. Y less than or equal to 3 mean all those values which are less than 3. So these will be also these, but I am shading here only the common values that satisfy all these region, all these inequalities. So this will be y less than 3 here. The last one, x plus y greater than or equal to 2. This shows, as this line shows x plus y equal to 2, so all those values which are above this line represent x plus y greater than or equal to 2 here. So x plus y greater than or equal to 2 here, this represent x plus y greater than or equal to 2. So this is the common values that satisfies all these 3 inequalities. Next one. In the diagram, A is a point 6,3. This is your point A63 here. 6,3. I should change the color. This is A63. C is the point. This is your point C, -8, -4. The equation of line AB is y is equal to 3. This line has the equation y is equal to 3. So the students, we will discuss the remaining part after Aftari. So let us take a break. Okay. Okay. We are discussing question number 7, and we are here. The equation of CB is y is equal to x plus 4. This line has equation y is equal to x plus 4. The first part, find the coordinates of B. As you see, B is in the intersection of two lines. One is y is equal to 3, that is actually the line AB. And the second one, B is in the intersection of line BC, whose equation is, say this is equation number 1, and the second equation is y is equal to x plus 4. This is equation, say this is equation 2, this is equation of the line CB. We need to find the point of intersection B here by just substituting the value of y from equation number 1 into equation number 2. We have 3 is equal to x plus 4. This implies x is equal to 3 minus 4, that is equal to minus 1. This implies the coordinates of B is x is equal to minus 1 and y is equal to 3. Next, the unshaded region R inside the triangle ABC is defined by three inequalities. One of the inequalities y less than x plus 4. Firstly, y less than x plus 4. This shows the equation y is equal to x plus 4. Now, here y is less than x plus 4. It means this is the inner area here that represent the inequality y less than x plus 4. We just need to find the two other inequalities. First of the inequality is given by the line y is equal to 3 here. This is the horizontal line y is equal to 3. As you see, the unshaded region R is below this line. Suppose there is a person here on this line, then the unshaded region R is below this person or above this lies below. It means the one of the inequality opposite to inequality opposite to line or equation y is equal to 3 is y less than 3. One of the important point is that although the line in the graph are solid line, so this should be y less than or equal to 3, but in the question it is given that the opposite inequality to this line, this equation y is equal to x plus 4 is represented here y less than x plus 4. So according to the question, or by using the symmetry of question, we will take the opposite inequality by y less than 3. But you can mention in question as the lines are the solid, so we should take y less than or equal to 3 here. The next inequality is this is given by this inclined or oblique line. So firstly we need to find the equation of this oblique line. You can see here this oblique line passes through the 2 points A, C, and one of the point is origin O. So firstly we find what is the gradient of this line. The gradient of this line is, suppose the gradient of line is m, then it is 6 minus 0, y2 minus y1, that is 3 minus 0, over x2 minus x1, 6 minus 0. This is equal to 1 by 2 here. So gradient of the line is 1 by 2 here. Gradient. Next, by using formula y minus y1 is equal to gradient x minus x1. Put y1 is equal to 0, gradient is 1 by 2, and x1 is equal to 0. this represent 1 by 2x. Now the unshaded region R is here, and the equation of this line is y is equal to 1 by 2x. Now unshaded region is above or below this line. Suppose you are here at this line. Now unshaded region is above here. Suppose you are this at this line, unshaded region is above. So the opposite inequality is y greater than 1 by 2x. So next we move towards the next question. Question number 8, paper 2007, paper 1, question 8. The unshaded region inside the triangle is defined by the three inequalities. One of the inequalities is x plus y less than 5 half. Write down the other two inequalities. Firstly, we find the line opposite to the equation of this inequality. The opposite equation to this inequality is simply x plus y is equal to 5 and half. That you can write 11 by 2 or further 5.5 here. Okay, so this is x plus y is equal to 5.5. If you convert it into two-intercept form, or simply if you find y or x intercept to identify which line represent this equation, I am going to put x is equal to 0 here. We find y is equal to 5.5. Where is y 5.5? You can see this point represent y is equal to 5.5. Here y is 5.5. It means this line, this dotted line represent the equation x plus y is equal to 5.5. Now I need to find the other two inequalities. So for this, firstly we find what is the equation of these two dotted line, 1 and 1 this. So let us find the opposite inequality, opposite equation to this inequality, this line, dotted line. As this line passes through 2 points which are clear on the grid. One is this, here x is equal to 2 and y is equal to 1, and the second one is origin, this one. So I will use these 2 points, and firstly I find what is the gradient of this line AC. Actually this dotted line is AC. So firstly we find gradient of AC, gradient of line AC. Suppose the gradient of line AC is represented as, I am using point, one is x1, y2, and the second one is origin, 0, 0. Formula is y2 minus y1, 2 minus 0, over x2 minus x1, 1 minus 0. This is equal to 2. By using the slope point form formula, y minus y1 is equal to gradient of line AC, x minus x1, y minus y1. What is y1? y1 you can use here 0 as the y1 and 0 as x1. 0, 2, x minus 0. This is equal to y equal to 2x. So the equation of this line is y is equal to 2x. Y is equal to 2x, sorry. Now, what is the opposite inequality? You can see here the shaded region. This shaded region is below or above this line. Think it. This is below. This lies on the below side. So the opposite inequality, you will write here opposite inequality to the line y is equal to 2x that satisfies shaded region is y less than 2x. Again, suppose if you mistakenly take y greater than 2x, you can verify it by taking any point in this region. Suppose you take this point from this region, the coordinate of this point is 2 2. If you put y is equal to 2 here and x is equal to 2 here, you get 2 greater than 4. That is false. It means the correct sign is less than sign. Further, as line AC is a dotted line, so the opposite inequality just contain less than sign rather than less than or equal. Next we find the equation of line BC. This line BC can be found by using two intercept formula. The next one is yes, sorry, one of the line was given, that is x plus y is equal to 5.5. This is already given. Next remaining line is the horizontal line here. This is our next line. If you see here, this line y x is equal to 1, this line is last line. The third inequality is as the shaded region is above this line. If you are here on this line, then the shaded region is above. So the last inequality is x greater than 1. Sorry, this is a horizontal line, this is y greater than 1 here, sorry. So these are the three inequalities. Next, in the B part, how many points with integer coordinates lies in the shaded region? So one of the point in the shaded region one is this x2, x2, y2. The second one is this x2, but the height is 3 now. The next one is this, when x is 3 and y is 2, x is 3, y is 2. But just these are the 3 points that lies in this region. Suppose if you are thinking why here we are not considering the point x41, then I want to say x41 is not a part of this region. Actually this point lies on this line. So we will consider only those points that lies in this region. The next one, question 9. The diagram below shows the line 2y is equal to 4 minus 3x. This is given graph of the line 2y is equal to 4 minus 3. Draw the line y is equal to half x minus 2. We need to draw the graph of line 1 by 2x minus 2. One of the method to draw the graph of this line is we find its x-intercept or y-intercept, or the second one is that we convert it into two intercept form. So if we multiply this equation by 2 on both sides, we get 2y is equal to x minus 4. By shifting 2y on the right side and 4 on the left side, we have x minus 2y is equal to 4. By dividing on both sides by 4, we have x by 4 minus 2y by 4 is equal to 4 over 4. This becomes x by 4 minus y by 2 is equal to 1. The number in the this line further can be written as x by 4 plus y over minus 2 is equal to 1. Now the number below x is equal to 4 shows x-intercept. So x-intercept of the line is 4 and the y-intercept is minus 2. So to draw the graph, firstly we just locate or plot x or y-intercept. Where is x is equal to 4? This is this point. Represent x is equal to 4. Where is y-intercept? Minus 2. This point represent y is equal to minus 2. Now joining these two intercept, we have the graph of required line. So this is the graph of line. Y is equal to half x minus 2. Next one. Shade and label the region are defined by the following inequalities: x greater than or equal to 0, x greater than or equal to 0. Corresponding equation to this inequality is simply x is equal to 0, and x is equal to 0 represent y-axis. So firstly we draw x is equal to 0 here. X is equal to 0 means y-axis. So this line represent graph of x is equal to 0. Next one. The next inequality is 2y less than 4 minus 3x. 4 minus 3x is here. Two y less than 4. If we plot the graph on the same line, it will be easier for us. This represent x is equal to 0. Now we need to find numbers that are on the right side of x. X greater than or equal to 0 mean all those numbers which are on the right side of x is equal to 0. So this represent x is greater than or equal to 0 here. 2y less than 4 minus 3x mean to say number on the below this line. So this shows number below this line. This red area shows the graph of 2y less than or equal to 4 minus 3x, the last one. Y greater than half x minus 2. This is this line represent y is equal to half x minus 2. But we need to find the opposite graph of opposite inequality, y greater than or equal to half x minus 2. Suppose you are here. Now we need to find all those numbers which are greater than y is equal to half x minus 2. So in which direction you will graph, below or above? above. You will graph above to this line. So this is the region R that satisfied all the inequalities. Again, if you have confusion about in shading the graph of the inequalities, you can take any point as a test point and check whether it satisfied the given inequality or not. My claim is that this is my required region R. Suppose I take this point. Suppose I take this point. This is x is equal, here x is equal to 1 and y is equal to -1. If I put this point in any of the line, you can see this point will satisfy all these inequalities. Suppose first if I put x is equal to 1 here, you can see 1 is always bigger than 0. The next one, if I put x is equal to 1 and y is equal to -1 in this inequality, the second inequality, 2 into -1 less than or equal to 4 minus 3 into 1. This is -2 less than or equal to 1. This is true. This shows that a point from this region satisfied also second inequality. If you put the point of this region into the third inequality, that is y greater than or equal to half x minus 2. What is y? Y coordinate of this point is -1 greater than or equal to half x. What is x? X is 1 and -2. This gives us -1 greater than or equal to -3/2. You can see -1 is always bigger than -3/2. This shows that the required region, the point in the required region satisfied all of these inequalities. It means you have correctly shaded the region R. The next question number 10. Same year 2008, paper 1, question 22, and the marks of these questions are we will discuss in the 2, 1, 3, 3 plus 2, 5 marks. And here the marks was 2 plus 1, 3. It means in 2008, total marks of this topic was 8. 8 plus 3, 11. So the equation of the line L is x plus 2y is equal to -1. Write down the gradient of the line L. My line is x plus 2y is equal to -1. I need to find the gradient of the line. Firstly, I convert this into, in this form, y is equal to mx plus c, slope gradient intercept form. This can be written as -x minus 1. By dividing 2 on both sides, we have minus half x minus 1/2. So the gradient is minus 1/2 here. Find an equation of the line parallel to L that passes through the point 0,5. The required line is simply here y is equal to minus half x minus plus 5. Alternatively, you can see here, you can give a reason, two parallel lines have same slopes or gradient. Slopes mean gradient. They have the same gradient. It means the gradient of the required line will be -1/2, and the further y-intercept of this line is 5, and c also represent y-intercept. So this is our required line simply. The diagram in the answer space shows the line L and the line 2x plus y is equal to 2x plus 1. We'll move in the next page. Y is equal to 2x plus 1. This represents the graph of y is equal to 2x plus 1, and this is our required line L. The required line L is required mean given line x plus 2y is equal to minus 1. This is the equation of line L. Draw the line y is equal to minus 2. As you know, line y is equal to minus 2 is a horizontal line. Where is minus 2? This point represent minus 2. So the line y is equal to minus 2 is a horizontal line. So this represent y is equal to minus 2. This is line y is equal to minus 2. The second one, shade and label the region are defined by three inequalities. We have to shade the region that is satisfied by all of these inequality. Y greater than or equal to minus 2. Y greater than or equal to minus 2 mean, suppose you are here at this location. Now y greater than or equal to minus 2 mean all those values which are bigger than minus 2. It means these would be minus 1, 0, 1. So the graph is above side. So this area above, this area also include this line, this, but I am shading here only that area that is common to all of these inequality. Otherwise this area also shows y greater than or equal to minus 2. So I am shading here the common area. The next one, x plus 2y less than or equal to minus 1. This shows, this is line y, x is equal to x plus 2y is equal to minus 1. Now here the sign of the inequality is less than or equal to minus 1. It means the area is below the line. Less than or equal mean below the line. So the required area is below this line. This line here. Yes. The last one, y greater than 2x plus 1. In which direction we will shade here? In this direction or in this direction? Decide it. I need to find all those values in which y is bigger than 2x plus 1. Y is bigger than 2x plus 1 here. So the required region. Suppose you are unable to decide the direction. You can simply take any test point from both sides. So your shaded area for this inequality is either on this side or in this side, and you are unable to decide here. You can take simply a test point here. Suppose you say area is in this side. You can take a test point of this region. This is y is equal to minus 1 and here x is equal to 0. This is y-intercept. So if you put y is equal to x is equal to 0 or y is equal to minus 1 in this inequality, suppose you say the shaded area for this inequality is on the right side. Put y is equal to minus 1 greater than or equal to 2 into 0 plus 1. This will give us minus 1 bigger than or equal to 1. Is this true? No, this is false. It means the shaded region for this inequality is not on the right side. This will be on the left side. So the area shaded by this inequality is in this side. So this is the common region. This is the common region R, which is satisfied by all of these inequalities. So I hope today's lecture is helpful for you. Inshallah, in the next lecture, we will discuss the next PYQs from 2009 to next. If you find my videos are helpful for you in any way, kindly like, share and subscribe my channel. Okay, take care. Allah Hafiz.